everyone, welcome to the video lecture series of operating system. In today's session, we are continuing with the topic memory management. Myself Kunal Panchal, your instructor. In today's session, we are going to discuss non-contiguous memory allocation policy, specifically paging. So before directly jump into the paging, which is non-contiguous memory allocation policy, let us recall our previous lecture contains in which we have discussed contiguous memory allocation with its pros and cons. So as you know very well, with respect to memory management, operating system has two main responsibilities. One is memory allocation policy and second one is address translation. That we have discussed already with respect to contiguous memory allocation. Okay. In contiguous memory allocation, what are the disadvantages with it? One is internal fragmentation and second one is external fragmentation. Means contiguous memory allocation suffers from internal as well as external fragmentation. But internal fragmentation is not that much severe as compared to the external fragmentation problem. Why? Because in the case of external fragmentation, even though we have enough space to accommodate the process, but that space is not available in contiguous fashion. That is the reason why we cannot accommodate that process into the memory for execution. Okay, so that is the scenario of external fragmentation. It is nothing but external fragmentation. So definitely it is more severe as compared to internal fragmentation. Yes, so that is the reason why we need to switch from contiguous memory allocation to non-contiguous memory allocation. Okay, so let us discuss the non-contiguous memory allocation and then we will see whether the internal as well as external fragmentation is present in this case or not. So let us start with the first policy of non-contiguous memory allocation, which is nothing but paging. It's one type of technique that we have in non-contiguous category. Okay. So before going to discuss paging, we need to understand the basic funda of contiguous and non-contiguous memory allocation. Okay. With its advantages and disadvantages. Then you can able to understand the concept of paging. Because in memory management, paging is very important as far as any type of examination is concerned. Okay, so you need to keep these things in your mind and you need to understand this concept very well. Okay, so as you know very well, the memory architecture or we can say memory hierarchy that we have seen in the previous session. So in this particular figure, there are two types of memory we have. One is secondary memory and another one is main memory. So what is the scenario in the case of paging? So basically paging we are using to avoid or to resolve the problem of external fragmentation. So how we can resolve it, let us discuss with this figure first, then we'll switch to the main architecture of paging. So in this particular figure, there is one secondary memory, and secondary memory is divided into a fixed size partition. And each partition size is same. Yes, so that you need to keep in your mind. Why we are doing these things? You will understand, or we will discuss that stuff later on. So what will happen in this case? Secondary memory is divided into a fixed size partitioning. Again, in the case of paging, we are using fixed size partitioning policy. Okay, so because even though it suffers from internal fragmentation, still we are using fixed size partitioning policy in the case of paging. Okay. Why? The reason behind it you will understand once we discuss this concept of paging. Okay, so initially the secondary memory is divided into a fixed size partition and each partition size is same. Okay. Now secondary memory is working at the backup side and at front side we have a main memory, and you know very well why we are using the concept of memory hierarchy, because to achieve three criteria that we have discussed in the first lecture of memory management. So that is the reason why we are using this memory hierarchy concept. Okay, that three criteria is nothing but size, access time, and per unit cost. These three criteria we need to achieve simultaneously. That is the reason why we are using the concept of memory hierarchy. Okay. Now these different partitions, fixed size partitions of secondary memory, these partitions we call as pages in the case of paging. So what is pages? Pages is nothing but the fixed size partition that we perform in the secondary memory. Okay, so that is all about secondary memory. Now, if you talking about main memory, what will happen? Because ultimately we need to resolve two issues. One is address translation and second one is space allocation policy. So first of all we will discuss the space allocation or memory allocation policy, how memory allocation policy will work in the case of paging, and once we understood that stuff then we will talk about address translation, because both are required simultaneously to execute any process in the CPU. Yes, both these things are satisfied first, then and then we can execute any process in the CPU. Okay, so the same size of partitions we have performed in main memory as well. Okay, it means size of the partition in secondary memory is equal to the size of the partition in the main memory. But these partitions in main memory called as frames instead of pages. Okay, the partitions of secondary memory we can call as pages, and partition in the main memory we can call as frames. Okay, now if we have one process, let's say for example x1 in this case, and if this particular process contains number of pages like p1, p2, p3, and p1, p2, p3 are stored in the secondary memory in continuous fashion. Because P1, P2 and P3 are in serial manner. Okay, so it is not required to have this process stored in the secondary memory into a continuous fashion only. It is not required. It can be stored in non-contiguous fashion as well. It can be stored in index allocation as well. Okay, so but right now we are assuming the process which is stored in secondary memory is stored in the form of contiguous memory allocation. Okay, in contiguous form. Okay, but this x1 process, because size of secondary memory partition is equal to the size of the main memory partition. Yes, so what is the advantage by having the same size of partition in both the cases? Yes, like if you as far as this pages is concerned, if you pages is analogous to the real life situation of your book. If you have various size of partitions, yes, in this case it will be difficult to manage that stuff. Like in real life situation, if you have a book and if book contain various size of pages, okay, it will be very difficult to manage that book. But if each and every page we have in same size, then the things would be easier to manage. So same concept is applicable in this case. So that is the reason why we have partitioned the various types of memory, secondary memory as well as main memory, into fixed size partition, and each partition size is same. Okay. So, but once you, because if you want to execute any process, that process needs to be residing in main memory. So right now, this X1 process is resides in secondary memory. So we need to shift from action process to a main memory from secondary memory. So once you store that stuff in main memory, there are chances some of the blocks in main memory is already occupied. So what you need to do is, because we are talking about non-contiguous memory allocation, because paging is one technique which supports non-contiguous memory allocation. So whenever you find a space to store that particular page in main memory, you can easily store it. Yes, so you can see in this particular figure, the second block in main memory is already reserved or occupied. So we can store P1 in the first block, P2 in the last block, and P3 in the third block. And P2 is second block is already occupied, so we cannot utilize it. Yes, because of non-contiguous memory allocation, it is possible to store this space in non-contiguous fashion. Okay, so these things you have to keep in your mind. Now we are moving towards the actual architecture of paging. So in this particular concept, as we have discussed, the size of each partition is same in secondary memory as compared to the main memory. So that concept we are taking forward in this case as well. Now, what will happen? Because now you have taken that process from secondary memory into main memory. Now the CPU needs to access your main memory. Yes, for execution. Because pages are loaded into a main memory. Now these pages are ready for execution. But now CPU needs to access this main memory. But there is one problem. Okay. What is the problem? Because CPU always generate logical address, and through logical address, CPU can access secondary memory directly. Yes, but we need to access main memory. So we need to convert this logical address into physical address, so that we can directly contact to a main memory and fetch the pages for execution. So again, there is one issue called address translation. So we need to have address translation mechanism in between CPU and main memory. So that translation mechanism we need to implement. So because space allocation policy we have already understood. Now how address translation will work in the case of non-contiguous memory allocation. Because address translation we have discussed already in the case of contiguous memory allocation. But in this case, pages are located into different locations in main memory randomly. It is located in a random fashion. Yes, because it is non-contiguous. So how we can access those pages for execution? Yes, so that is one problem. So how we can resolve it? So CPU will always generate logical address. So you can see the CPU generates a logical address, and this logical address is divided into two fields. One is P and second one is P. So what is P and what is D? P stands for page number and D stands for displacement, or you can say instruction offset. Okay. So these things you have to keep in your mind. So once CPU generate logical address which contains two fields, one is page number and second one is instruction offset. So what is instruction offset and what is page number? Suppose if you have a document and if I say try to read the line number 179. So it is somewhat time consuming approach to find out or to reach to that particular line and read it. It is time consuming approach. But instead of this, when I say go to page number 45 and try to read the line number 179. So in this case, you will find that particular sentence easily. Okay, or you can say very fast, efficiently you can find it out. Efficiently you can reach to that particular sentence. Yes, same concept is applicable in this case. What will happen? So P is nothing but page number. So which indicates where you need to go. Okay, and D stands for displacement. Means what it is nothing but instruction number or you can say sentence number or you can say line number in the case of real life scenario. If you are talking about book. Yes. So suppose we have this logical address. Now we need to convert this logical address into physical address. But how we can reach to the physical address so that we can access the main memory for execution? So there are two things through which we can do these things. Either we can go for contiguous memory location that we have already understood through which we can do the address translation easily. But there is one problem when we are dealing with contiguous memory location. We don't want the page needs to be stored in contiguous fashion. Why? Because in the case of contiguous memory location, it suffers from external fragmentation, which is very severe problem. So we don't want to use contiguous memory location. Okay. Second one, in the case of second case is what? Either you can store the page in the form of linked list. Means you need to have one starting address of a particular page. Okay, which store the address of the another page. Then second page store the address of the another page. Like that, you can reach to an nth element or you say nth number page. Okay, in the main memory. But again, this strategy is time consuming. Yes, if you store this page in form of a linked list, and if you want to reach to nth node, so definitely you need to search that element in a sequential manner, in a linear fashion. So it is time consuming approach. So it is not advisable to use in this case. So in this case, we neither go for contiguous memory location, nor we need to store these pages in the form of linked list. So what we need to do? Okay, because we have stored that pages in non-contiguous fashion, now we need to access it. But the problem is what? If you want to access this page, you need to have physical address. Yes. So how we can compute the physical address? So what we can do is, by computing the physical address, you have to keep these things in your mind. Your access should be fast as compared to the linked list approach. Okay, so what we can do is we can create one data structure. Okay, which is nothing but page table. Page table. Page table is not a hardware. It is nothing but one type of data structure we can create and maintain in the main memory, and which contains the address of the frame number through which we can access the page in main memory. Okay, because the various partitions we have in main memory is called as a frame. So a page table is one type of index table. So with the help of index value, we can find out the base address of a particular frame, and then we will reach to a particular frame in main memory in which the page is loaded. Okay, so how we can do it? So with the help of page table contains things. One is index value of a page, and second one is nothing but the frame number. Actually, it is nothing but the base address of the frame of whatever the page number we have. Okay, so we need to, so page table contains how many entries? So entries of page table is depends on the entry in the secondary memory. How? Means the secondary memory contains various processes, and each process may have various pages, or we can say yes. So the number of entries in page table is equal to the number of pages in a process which resides in secondary memory. This sentence is very important. Suppose you are talking about x1, which in secondary memory, which contains 3 pages, P1, P2 and P3. So as far as this example is concerned, how many entries should be there in the case of page table? As far as x1 process is concerned, 3 entries, P1, P2 and P3. So P1, P2 and P3 index we should have, through which we can find out the base address of P1, base address of P2 and base address of P3. Okay, so now let us discuss this whole architecture in detail. So CPU always generate logical address. Suppose if CPU require a page number 2 and instruction number 32, that needs to be accessed by the CPU for its execution. So what will happen in this case? So that request will be forwarded to the page table first. So which page number it requires? So P2, second page number, P2 page number is it requires for its execution. So that request will be forwarded to the page table first, and according to the index of the page value, which is nothing but P2 in this case, we can reach to the base address of P2. So with the help of page table, which contains the base address of the various frames that we have in main memory, which is located into a page table. These things you have to keep in your mind. Page table is located into a main memory. So, but page table is not part of process control block. It is not a part of process control block. There is one separate table which is stored in main memory, and that table we can access with the help of PTBR. What is PTBR? PTBR stands for page table base register. Page table base register means page table base register which store the starting address, or is it base address of this page table, where you can access this page table in main memory. Okay, so what is the, so CPU wants to access this page table, how it can access? So you will access the PTBR, through which PTBR is a special type of register which store the base address of, what is the starting address of the page table. So with the help of PTBR, we can reach to page table. Now, once we access the page table, I need to go to a P2 page. So based on the index, I need to reach to a P2 page, and once you go to a P2 index in page table, you will find the base address of P2. Yes, base address of P2. So with the help of this frame number, or we say base address of that frame, we can compute the physical address. How? So frame number of P2 we can fetch, and displacement value will not change. Why? Because if I say find out 179 sentence number, okay, or if I say page number 31, find out page sentence number 139, in both the cases the sentence number is not changed. Yes, so displacement value or instruction offset, yeah, carry carry forward in this case as well. So it will not change in the case of logical address, okay, to compute the logical address, as well as it will not change to compute in the case of physical address. Okay. So once you compute the physical address, now you can easily access the main memory, because with the help of physical address you can read the content, or you can access the main memory. Yes, and once we have the physical address, we can find out the frame number, and according to the frame number, we can reach to the particular page, which is nothing but P2 in this case. So arrow pointed out, we need to find out the page number P2, and P2 will be fetched by the CPU and execute there. Okay. In this way, we can access the pages from the main memory in the case of paging technique. So, what are the advantages and disadvantages of paging technique? So, paging technique is faster as compared to the linked list fashion. If you store the pages in the form of linked list, in that case searching would be very slow. The system will be very slow to access a particular page for execution or particular process for execution. But if you maintain this page table, one separate data structure, and in which you can store the frame number, so whenever you find any page, you need to find out the corresponding frame number of it, and with the help of frame number, you can easily fetch those pages from the main memory. So searching would be very fast. But second advantage is what? This paging technique never suffer from external fragmentation, and that is nothing but our main objective. It never suffer from external fragmentation because it follows the non-contiguous fashion. Okay, but what are the limitations of your paging technique? So we need to pay a high penalty, because if you want to access a particular page, you need to access the main memory twice. So if you access 2 times main memory, so searching time would be half. So that is a disadvantage of paging. Yes. So I hope this paging technique is clear to you. Paging is categorized into a non-contiguous policy, and it uses the concept of a page table, which is nothing but one special data structure, we can say, which contains the frame number, and frame number can be accessed with that of index of the page values. Okay, so I hope it was clear to you. Thanks for watching this video. See you in the next one.